Okay, so we're still on the third quarter review, and we're at the bottom of page 2 now, problem 15. We're solving a system of equations, so one method for solving a system is substitution. If y is equal to all of this, you can substitute all of that for the y in the second equation. So I'm going to rewrite the second equation, 2x plus, but instead of writing the y, I'm going to write everything that equals the y. 3x squared minus 2x minus 1. Then continue with the minus 11 equals 0. Alright, so now we need to combine like terms. So 2x and negative 2x, that's going to cancel out. I have 3x squared minus 12 equals 0. I can divide both sides by 3, and I get x squared minus 4 equals 0, which you can solve by factoring or just simply by solving for x. X squared, let's just add the 4 to both sides. So x squared equals 4, and when you solve that with a square root, remember your plus or minus. So x is going to equal 2, or x is going to equal negative 2. So then you need to find the y values by plugging back in. And you can plug back into either equation. The second equation might be easier because it doesn't have a squared, it's not quadratic. So the second equation, if I were to move the 2x and the 11 to the other side, the second equation would be y equals negative 2x plus 11. And then I'm going to substitute in 2. So I have negative 2 times 2 plus 11, and I get negative 4 plus 11, which is 7. So that point would be 2, 7. And then I'm going to try substituting the negative 2 in. Y equals negative 2 times negative 2 plus 11. 4 plus 11 is 15, so I get y equals 15, and that point will be negative 2, comma 15. So I'm going to box those two answers up. Okay, to sketch the inverse of a graph, remember that in the inverse, the x and the y switch. So you can find 2 points on the graph, for example, this one, and you just want to switch the x and the y. So my first point is negative 4, comma 0, and when you switch the x and y, it becomes 0, negative 4. So that point's down here. The second point is 0, 2, and that point becomes 2, 0, and that point is right here. So you're going to sketch through those 2 points like so. Alright, let's go to page 3. It says use a calculator to sketch the graph of this polynomial. And then we're going to use that to state the domain and range and answer all these other questions here. Okay, so let's pull up the calculator and go to y equals, clear what's in there. Alright, 1/2 x to the 4 plus 2 x to the 3 minus x squared minus 6x plus 4.5. And graph. Okay, so you can see the shape of the graph. You can see that it has zeros at 1 to negative 3 and at positive 1. And the y-intercept's a little bit hard to read, but let's look at the equation to see if we can figure that out. So I'm going to graph my intercepts at -3 and +1. 1 to -3. Oops, and +1. Remember that your y-intercept is when the x is 0. So if this is 0, 0, 0, 0, that means your y-intercept is 4.5. 1, 2, 3, 4.5. Okay, and then we can use those points and sketch in the shape. Your graph should be a little curvier than this one. It's a little hard to draw with a smartboard. Alright, state the domain and range. So the domain is going to be from the left, -infinity, and then continuing to the right, +infinity. Okay, the range starts at your smallest y value, which seems to be 0, and then it goes up to +infinity. Alright, your end behavior, always going to start with as x goes to -infinity, f of x goes to, as x goes to +infinity, f of x goes to. So as x goes to -infinity, that's the left side. The y is going to +infinity. And as x goes to +infinity, that's the right side. We're still going to +infinity. Alright, the x and y intercepts, we found those on the graph originally. So your x-intercepts, we said -3, 0, and 1, 0. And your y-intercept, we found that by substituting 0 for all the x's, and it was just your constant term. And that was 0, 4.5. Alright, increasing intervals, you read your graph from the left to the right. So it starts by decreasing, and then it's increasing, and then decreasing again, and then increasing. So for the increasing intervals, we're looking at this part and this part. So it's increasing from when x is -3 until x is 0. And then it's increasing again from x is 1 until infinity. Decreasing was x is -infinity until x is -3. And then from 0 to 1. Okay, moving on. If these are the zeros of the polynomial, we want to write the factors. Now, if this is -5, then your factor is x plus 5. And if this is +3, your factor is x minus 3. And if you have a 1/2 here, you might start with x minus 1/2, but you can't have a fraction in your factor. So take that denominator and multiply the factor by that number. So if I multiply that by a 2, and I distribute it like this, that becomes 2x minus 1. And then the other factors were fine as they were. Alright, y varies inversely with x and directly with the square of z. So inverse variation is y equals k over x. Direct variation would be k times the square of z. So you can have both of those in the same equation. Direct is k times, inverse is k over. So now we're going to substitute these numbers in to find k. So we have 50 equals k times 5 squared over 4. And I'm going to multiply both sides by 4 to solve for k. So times 4 on both sides, that gives me 200 equals k times 5 squared is 25. And then divide by 25, and you get k equals 8. So the constant of proportionality, that is the k. That's what we just solved for. Now we're going to use that 8 and rewrite this equation. So you're going to use all your variables, but the constant k, you substitute 8 in. Y equals 8 times z squared over x. So what is the value of y when x equals 6 and z equals 3? Y equals 8 times 3 squared over 6. 3 squared is 9, times 8 is 72. So you have 72 over 6, which is 12. Alright, last problem on this page. We have a table, and we're trying to find out the polynomial to model the data. And then we're going to predict the number of runners participating in year 10. So we need to look at our data and try to figure out if it's linear, quadratic, cubic. Okay, so let's look at the data. The data starts at 230 and it's increasing until you get to 294. Then 294 down, it starts decreasing. Down to 268, and then it's increasing again. So if you look at that shape, increasing, decreasing, increasing, it has two turns, which would make it a cubic, third degree. So let's put the data in the calculator and do a cubic regression. Press Stat and edit your lists. And let's just take a quick look over and see what we have. First one is 1, 230. I'm going to put the inputs into the list 1. So 1, 2, 3, 4, 5, 6, 7. And then the outputs in list 2, 230, 274, 294, 289, 268, 275, and 290. Okay, press the Stat button again and go over to Calculate. And you want a cubic regression, which is choice 6. Okay, so here's your equation. Y equals ax cubed plus bx squared plus cx plus d. And you want to substitute the numbers in for a, b, c, and d. Okay, so let's see if we can copy this down. We can round to the hundredths place. So I have 2.36. So y equals 2.36 x cubed. Next one, negative 31.21 x squared. $125.42. X, and then lastly 132.43. Okay, so if we substitute 10 for all of your x's, you're going to put this in the calculator. Okay, so if you put this in the calculator, you should get an answer. We can also take a shortcut on the calculator. If we put this into your y equals, you could also look at the table of values. But in this case, I think I'll just practice it this way. So remember, 10 to the third is going to be 1,000. 10 squared is 100. 10 is just 10. So I'm just going to substitute that way. 2.36 times 1,000. Oops. And minus 31.21 times 100 plus 125.42 times 10 plus 132.43. Okay, so I'm getting about 625. Okay, so my answer would actually round better to 626 runners. And this is a little bit different from the answer key. So you should talk to your teacher about that. The equation right here is also different. One difference is that I didn't follow the directions here of rounding to one decimal place. So I have an extra decimal place here. But another difference is just that these numbers are slightly different. So it's possible that we had used slightly different data. Check with your teacher on comparing the two models and the final answer.